everyone and welcome back. In this video we are going to explore the second chapter, descriptive statistics. Have you ever wondered how scientists turn raw biological data into meaningful conclusions? Whether we are studying the growth of plants, the behavior of cells, or the spread of disease. Think about the COVID 19. Every day we were exposed to data, the number of new cases, deaths, recoveries, etc. But how did scientists and governments make sense of all this information? It's a really very important question. So, one essential tool statistics. We are going to discover how to make data talk. By the end of this chapter, you will be able to organize, visualize, and interpret real data like a scientist. In this chapter, you will cover 5 case sections. We will go step by step, starting from basic definitions to type of variables to how we organize and summarize real-world data. Let's begin with the basic concept. So, let's take a step back and look at the bigger picture of statistics. Here, let me tell you, we usually start with the population, the entire group we want to study. But in most real world situations, it's impossible or impractical to measure everyone. So instead, we select a sample, which is a smaller group that we are or we can actually observe. From that sample, we collect data. This is where descriptive statistics come in. It helps us organize and summarize the information gathered from the sample using tables, charts, and key indicators. Else, if we want test hypotheses or predict trends, we use inferential statistics. But in this chapter, we will only stay in the world of descriptive statistics. Now, let's imagine we are studying a disease. We will call it disease X. We have collected data on 4 different characteristics of the patients. First, we record each patient's blood group. Second, we counted the number of symptoms observed per patient. Third, we measured the C-reactive protein level in the blood, the values expressed in milligram per liter, and fourth, we record the severity level. Now, take a moment to observe these variables. What do you notice? The nature of the values, what we call the modalities, is different for each one. Take as example, blood groups has values like A, B, AB, or O. These are qualities, not numbers, and there is no logical order. So that's a qualitative nominal variable. Number of symptoms, on the other hand, gives values like 1, 2, 3, or 4. These are countable and separate numbers. So this is a quantitative discrete variable. C-reactive protein level can take values like 4.2, 6.7, etc. These are continuous values on a scale, so this is a quantitative continuous variable. For severity level, for example, mild, moderate, or severe. These are qualities, not numbers, but there is a natural order here, so it's a qualitative ordinal variable. So we have covered the 4 types of statistical variable, qualitative variables with 2 types, nominal and ordinal, and quantitative variables with 2 types, discrete and continuous. Understanding this classification helps us choose the right tools to analyze and represent data. To organize our data, we use statistical tables. The structure of the table depends on the type of variables. For qualitative variables, we list the categories and show frequencies, which means how many times it appears. And for the quantitative variables, the table can include not only frequencies but also numerical values. Let's see an example of a qualitative variable. In this study, we are interested in the flower color trait in balsam plants. We obtained purple, pink, lavender white, and white. Let's go step by step with this example and try to understand how we define each statistical element. First, we ask ourselves, what is our study about? It focuses on a group of balsam plants. So that's our population, or the balsam plants we are observing. Then we ask, what are we trying to study about these plants? In this case, we are interested in the color of their flowers. That's the statistical variable. It's the characteristic we are observing. Now, let's look at the modalities. Here we have four different flower colors. If we look closely at these values, we notice that they are not numbers, they are qualities, and there is no natural order between them. For example, purple isn't more or less than pink. So we say that this variable is qualitative nominal variable. Now that we have identified our variable and its modalities, we can organize the data in the following statistical table. Next, we can visualize the data using a bar chart or a P chart. Now let's move to a discrete quantitative variable, but this time we won't go through all the steps again because the reasoning is the same. For example, let's say you have a group of 20 patients and we record the number of symptoms they experienced during their illness. The possible results are isolated values like 1, 2, 3, or 4. That's why it's a discrete quantitative variable. The way we define the population, the variable, and the type is exactly the same as before. The main difference is that now we are working with numbers. So, the statistical tables involves calculations. As you can see here, the table is quite large, so I have had to split it into two parts. Honestly, you might even enjoy the calculations. It's more fun than it looks. And for the graphical representation, we typically use a bar chart, a frequency polygon, and a cumulative curve. You might notice that the cumulative curve looks like a stray case. That's why it's sometimes called a strap graph. Moving now to the continuous quantitative variable. As I mentioned earlier, in this situation, the data are not individual values, they are grouped into intervals or classes. Well, let's now imagine we measured the height of a group of students in meter. We'd get values like 1.58, 1.64, etc. These are not isolated numbers, but values that come from a range. So we group these values into intervals. And since we are dealing with intervals, we use the class midpoint or the center as a representative value. Okay, just like before, we can build a statistical table and we use similar graphs, histogram, frequency polygon, and cumulative curve. Now that we have seen how to organize and visualize data, let's briefly mention some statistical indicators. We have measures of position like the mean, median, and mode help us understand the central tendency of the data, and measures of dispersion like range, variance, and standard deviation tell us how spread out this data is. We will explore how to calculate and interpret these values in detail during the course. Now, let us provide a summary. In this video, we have discovered how to identify different types of variables, build statistical tables, visualize data, and understand the purpose of the key indicators. Don't worry if everything isn't clear right now. We will practice it step by step together. Thank you for watching.